Hi, so my name is Sebastian Witowski, and today I want to talk with you about continuous integration, or to be more specific, about optimizing your CI pipelines. So setting up a CI pipeline is not the easiest thing to do because now you have to deal with debugging things on a server that you don't necessarily control. And on top of that, there is this additional layer of complexity that you have to configure different services using some kind of config that your CI provider requires you to use. But usually with some kind of templates that we found on the internet, we can glue together some reasonable setup. That might work great when you start your project, but as the complexity of your code base grows, also the complexity of your CI starts growing. You start adding more and more tasks, you start building different versions of your release packages, you have more and more tests, and it starts to get frustrating to wait for your CI run to finish before you can merge your code, or maybe to wait for half an hour only to see that the pipeline has failed in some later stage because you made some silly mistake like unused variable, and that made your linter unhappy. So in this talk, I want to take a look at a few ideas to consider when it's time to improve your existing continuous integration. So first, we'll have a look at some improvement to our Docker setup. Then we will look at running things faster, for example, by configuring jobs so they don't have to wait for other unrelated stuff. Then I will have a look at not running unnecessary tasks or stopping them earlier. And finally, if I have some time left, I will share some miscellaneous tips and tricks. If we want to discuss continuous integration, we have to choose some platform because different services like GitLab, GitHub, CircleCI, and whatnot, they all require you to configure CI in a different way. I mean, the general idea stays the same. You write some kind of a config, but the way you write this config file differs between CI providers. So unfortunately, it's not possible to take your GitHub config, move it to GitLab, and expect it to work out of the box. So for the purpose of this talk, I chose GitLab. And that's mostly because most of my recent projects are using GitLab. But also, according to this Reddit survey, this is still the most popular option. But I am in no way related with GitLab. I know that they have paid plans, but everything I will be talking about can be found in the free version. And I personally never used GitLab. My clients did. We also need to have some code that our CI will actually run on. So I created a simple project that you can find under this link. It's a Django project with a very simple to-do app. If you don't know Django, don't worry, you don't have to know it. I use Django for the simple reason that a simple Django app by default is slightly bit more complex than a bare-bone Flask or Fast API. Out of the box, we'll have some migrations that we have to apply, and we will have generally a bit more files lying around, so it feels a bit more real world. So this example project has a to-do app that interacts with a database. It has a bunch of requirements, so this is mostly to slow down the build process. And it also has some tests that are slow because they either sleep or perform some needlessly large mathematical operation. Again, this is to slow down tests, so we have some room for improvement. And the build process uses Docker and Docker Compose. Docker Compose will set up two services, a Postgres database and a web container. And the web image is built from a pretty standard Docker file. So we specify Python 3.10 base image, we run pip, and then we start the server. I'm kind of scared to use the pointer here, so it works. I'm not going to touch it. Yeah, so this initial setup has a pipeline that takes around 6 minutes to finish. It runs 3 jobs. So we have a build that builds a Docker image. Then we have a test job that runs some migrations, and then it runs test. This stage is actually badly designed because the first Docker Compose will actually build the Docker image from scratch. I will address this issue in a moment. And then finally, we have a deploy stage that only prints a message to the screen. But if you look here, you can already see that it takes 54 seconds. So those 54 seconds is the time it takes for GitLab to provision a new container for a job. So keep that number in mind. And of course, this is an example project that is simple for the demonstration purpose. It's absolutely not production ready. So maybe try not to copy it and use it in production. So I mentioned that my example is using Docker. Docker or containers in general are now a common tool in the DevOps world. They are also very well supported by most of the CI providers. So if you're planning to deploy your application to some cloud provider, using Docker inside of your CI is a good idea. But even if you do development without Docker, it's rather easy to wrap your application in simple containers. So if you do use Docker, the first step to improve your CI is to actually take a look at your Docker file and make sure you don't have some obvious problems. So make sure that you are using layers caching during your build time correctly. Make sure you use tags so you know which image you use in your builds. Speaking of images, which one of those two you think is better? Slimbuster, which is a Debian-based image, or Alpine, which is a pretty bare-bone small Linux image? Slim. Okay, so we have someone saying Slim. So if you use a Slimbuster, then you will have a larger image because you will have a lot of additional software that you don't necessarily need. So anyone here said Alpine? There are some people nodding heads. Yeah, but with Alpine, you actually have to install some additional tools even to be able to run pip. So there is no good answer here. If you use Alpine, it means that you will have to probably install some additional Linux libraries yourself. This will make your Docker file slightly more complex and the build process might be longer, but the final image will be smaller, so it will be much faster to download it or push it back to the registry. On the other hand, Slimbuster is twice the size of Alpine, which is still not that bad because if we use Buster, that's like 15 times the size of Alpine. So it will take longer to download, but chances are it will come with all the dependencies you need. So then you can just run pip install and you're ready to go. So in the end, the choice should depend on whether your pipelines spend more time building the images or pushing and pulling those images in your jobs. But Slimbuster is usually a good choice here. So one way we can also speed up our build time is to not build the Docker image in each job, but to actually build it once, push it to the container registry, and pull it in the consecutive jobs. So here we can see that even though we are building the Docker image in the build stage, when we run docker compose, it will also build the Docker image because jobs are independent. So the test job doesn't know that the image was built in the build job. We can fix that by pushing the container registry at the end of our build job and then pulling it at the beginning of the test job. And if we check this pull-push Docker image branch in my example project, we can see that now the build time takes a bit longer, but the test job takes less time. But of course, the differences here are tiny. Like those few seconds might come from the fact that it took a bit longer to provision the runner for our job. And actually, if we check the test job in my example project, you can see that building a Docker image takes almost the same amount of time as pulling the Docker image from the registry. But again, your mileage may vary. If your build process takes long and you have many jobs, then it makes sense to pull this image at the beginning of each job from the registry. But if your build process is simple and fast, then maybe it will actually be faster to just build the Docker image from scratch. So another thing you can do if you end up building massive Docker images is to use a multi-stage build. Multi-stage build means that you will be using a separate image for the build process. So you copy a bunch of files, you install plenty of dependencies for the build process, then you run the build process that might create some temporary files and some cache files and so on. And that image can grow in size, but you don't really care because at the end, you will just take the results of your build process and move them to a new image without all this cache, without all those additional dependencies. You mean the screen? Okay. Yeah, you can do this now. I don't need this. You saw the slide. Yeah, so the multi-stage works very nice in languages where the build step requires you to install additional Linux dependencies, but the result of the build is a single binary, for example, in Rust. In the Python world, it doesn't matter that much. Will it? Okay, let's give it a moment. So in the Python world, it doesn't matter that much. Like in my example, I'm not even installing any Linux packages in our Slim Buster. If I was using Alpine Linux and I was installing some additional Linux packages, then it might make difference, but in my case, it doesn't really matter. Let me get the slides back. They always move to the other side. All right. So let's leave Docker for now, and let's talk about CI pipelines. How can we make them run faster? So as your pipeline starts to grow bigger and bigger, and your stages, and in case you're curious what we are looking at, this is the pipeline of GitLab itself. So it's a pretty chunky boy. So you might want to look at the structure of your CI configuration and move things around. For example, instead of running your jobs in separate stages like here, we can run multiple jobs in one stage in parallel. So this pipeline will ultimately finish faster, except that what happens in one of the jobs fails. Now we are wasting computing resources running other jobs in this stage, even though we don't really care about the results of the static analysis or preparing the release, because we have to go and fix tests anyway. And there is actually an open issue about being able to cancel pending jobs if one of them fails, but it's open since 2018, so I would not get my hopes high that it's going to implement it any soon. So there are always some design considerations involved how you set up your pipelines, but in general, I would say that the time wasted waiting for the pipeline to finish, it's much more precious than a few dollars that you spend for the build minutes. So parallelizing things in general is a good idea. And there are two different ways how we can move things between stages. One way is called directed acyclic graph, or DAG, and you might know this concept from other tools. So with DAG, you can configure one job to start after another job, regardless of what stage they are in. For example, let's say you're testing your Python package under different Python versions, and for some reason you don't want to use a tool like Tox that can create multiple virtual environments with different Python versions. Instead, you decide to build different Python Docker images, and then run tests in those images, and then run releases. So here we have a, thank you. Here we have a build stage that has to finish before the test stage can start, and then we have the release stage. In the ideal world, all the builds will run in parallel and finish in more or less the same amount of time. In the real world, they won't. Like, some builds will take longer to finish, and for example, if you're using custom runners, that's okay. And for example, if you're using custom runners, then oh, do I even see that? Okay, let's give it a moment. If you're using custom runners, then maybe your jobs have to wait in the queue before they can even start. And in the case of this slide that we no longer see, what's the point of the test for Python 3.8 to wait for build of Python 3. That's where we can use DAG. So we can connect some jobs between the dependent. You saw the slide, just memorize it. So you can combine some jobs with their dependencies regardless of where they are in. So once the build job is done, then the test job can start, and then the release job can continue. And in terms of code, that's all we need. You saw it for a brief moment. There was this needs keyword where you have to specify which job has to finish before the next one can start. Well, I can drink water, actually. I never had so much time to drink water during my presentation. Well, you have to rely on your imagination. So DAGs are cool, but there is another way how you can connect jobs. So if you connect too many jobs using DAG, then that can be confusing. Oh, different colors, that's not intended. But OK, I don't mind the colors. You can also create a downstream pipeline. So you can create mini pipelines that will be triggered from your parent pipelines. Let's say you're working on a project that is using a separate tech stack for a backend and for the front end. Let's say it's a Django REST framework with React on the front end. So then you have your backend code in the backend folder and your front end code in the front end folder. And your backend tests probably don't depend on having your frontend up and running. And then also there is no point in having in running your backend test if you only change something in the frontend. Yeah. I'm wondering how long is it going to last. We're going for a high score here. Yeah, so in this case, we can create a separate pipeline for the backend and separate for the frontend. And in terms of the code, this is how we can implement it. So here we have two jobs, frontend and backend. And then in the trigger, we say that the frontend configuration is in this frontend/GitLab CI, backend is in the backend/GitLab CI. And then we have a strategy. So in the strategy, we say that the parent pipeline depends on the result of the child pipeline. So if the child fails, the parent also should fail. If we don't specify the strategy, the parent pipeline will continue running other jobs even if this child pipeline fails. And then finally, under the rules, we can see that we should only run this pipeline when something changed in the front-end folder or something in the back-end folder. So we don't run the pipeline if only something has changed. We don't run the back-end pipeline if only the front-end has changed. So what else can we parallelize? We can parallelize tests. And most of you who already use PyTest, you probably know that there is this plugin called PyTest XDist that you can run PyTest on multiple CPU cores. And this is great if you have multiple CPU cores, but if you don't, you can run your test across multiple runners. This is especially useful when you want to dynamically spawn new runners, so you don't have like one huge, expensive multi-CPU server up and running all the time, but you spawn runners dynamically. And in terms of code, we have to install the PyTest test groups, and then we specify the parallel option, and we specify two options that you cannot see anymore, but you can connect them to GitLab variables, and then that will run your PyTest in separate jobs. So here we can see, here we cannot see that I have a separate branch where the slides will be available at the end, so you will be able to follow. So here we will have like 5 different jobs for tests, and as you can see, as you cannot see at the top, with the build time, we got down from 6 minutes to 5 minutes, but in terms of cost, we basically doubled the cost because instead of running 3 job containers, we have 5 job containers for 5 different tests, and just starting a job container takes around 1 minute. So it will be faster, but it will be more expensive. One thing that we can also do, imagine things. You can also interrupt the job. So if you have a job running and you push some new code to a branch, then it no longer makes sense to run that job. So you can make your pipelines interruptible. And there are actually 2 parts to it. So in the settings, you can enable this auto-cancel redundant pipelines. And this will allow you to cancel the pipelines, but only when the currently running job is finished. So you can also, maybe you will see, you can also add a key to your configuration called interruptible true. And this will allow you to stop the job as soon as there is some new code. So if you have like a build job or a test job that's running, you can interrupt it in the middle of the run. You don't have to wait until the end of this job. But for example, if you have a deploy job, then you don't want to make it interruptible because you don't want to end up with like partially deployed code to your web server. You probably want to run this job and start another job as soon as possible. And another thing is to stop tasks in your job when it doesn't make sense to run it anymore. For example, if you require that your tests are passing in the merge request before the code gets merged, then what's the point of running the whole test suite in the master branch? You can stop after the first failure with the PyTest -x, because that's enough to tell you that, hey, there is something wrong with your master branch, and someone will have to run those tests locally anyway to fix them. So the job can start, and job can stop, and you can start another job. Yeah. So how else we can how else we can make our CI pipelines faster? Well, by not running things in the CI. So one of my biggest revelations was that not every check has to be done in every pipeline. For example, if you have a bunch of slow integration tests, you can run them only on your main branches. In my current project, the whole test suite takes around 40 minutes to run. So we just marked some of the tests as slow. And now we run only some of the tests on the merge request pipelines, and they take around 5 minutes to run. And then we run this whole slow test suite on the staging and master branches. So the merge request pipelines are faster, and we still get the results of the whole test run eventually on the master branch. And if you have like particularly slow jobs, you can run them manually or you can run them nightly. Yeah. So we got to the part with the random tips and tricks. Do we even have some time? Should I continue? All right, yeah. So one random tip and tricks is about caching. So you can define some cache in your pipelines that specifies, for example, that pip can cache their files and then installing pip packages will be a bit faster. But you can also specify cache policy. So by default, when you cache something in GitLab, at the beginning of the job, you pull the cache, you run the job, you push the cache. But for example, if your job is doing something destructive, you can disable pushing this cache back. So your job will just pull the cache, do whatever it wants, but it will not push things back. And with that, you can also select something called fast zip compression method, which allows you to select the compression level for your job. So you can select like the fastest method that will run, well, the fastest, but the cache size will be a bit larger. So, okay, I mean, let's go to the conclusions anyway. So, the takeaway from this kind of failed talk is that learn concepts, not tools. So, what I was showing you, well, showing you is a big word, was how to use GitLab CI. But I mean, whatever CI provider you use, there is a way to run tasks in parallel or sequentially. So once you know how that something can be done, it's just a matter of figuring out how to do it. I don't know why I'm still clicking the slides. There are no silver bullets in terms of a perfect CI. Like, should you use Alpine or should you use Debian Buster? Should you like build your Docker images in your job or should you pull them? The suspension is killing me. It really depends on your project. And not every check should be done in your every pipeline. All right, yes. Not every check has to run in every pipeline, so just make your merge request pipelines fast and your main branches pipelines thorough. And if you think that you only set up your CI once at the beginning of your project and then you don't have to touch it again, think again. Outdated CI is also a technical debt, so it will make your code review slower, it will delay important feedback, and it will make developers more and more annoyed. So do yourself a favor, check from time to time what can be improved there. But in general, a well set up CI can be a great tool in your daily work. Thank you very much for listening and partially looking. Yeah, we can go with questions. Yeah, of course, we can go with questions.
We can some questions. We can have 5 minutes more questions if you want. What's a good way to debug building of Docker images? I've literally spent days to find tiny pesky mistakes in the past.
Oh, I did the same. I have no way. Like, I literally spent like 3 evenings trying to figure out what's going on in my CI because like I thought Docker containers could not talk to each other, and then I realized it's about the Postgres startup time, so you have to wait for the health check of the database, and just web was starting too fast before the database started, and I was like losing my mind there. So I have no way how to debug it. This is complex stuff. You needed someone who knows this stuff.
Which custom runner executor you recommend, Shell or Docker executor?
Honestly, I have no preference. I think in my examples, in the example repository, I think I used Shell, and at work we used Docker. But, well, depends. If you're using Docker already, then probably Docker.
Would it make sense to use modern workflow tools such as Apache Airflow for more complex CI setups?
Probably. Like the main benefit of like GitLab CI and other stuff is that it's built into where you store your code. So like for simple and like more advanced pipelines, it's fine. Like GitLab seems to be like quite advanced with what you can do there, but like if you need something very specific and you feel like Apache workflow is a better choice, then yeah.
Do you run each test separately? It feels like that uses way more resources due to setup and destroy being done all the time.
If I run each test separately.
Do you run each test separately?
No, I just run PyTest and on everything.
Thank you very much. That was better.
Thank you.